This is sample problem 3, section 5.5.1, so in part 5 on newtons and forces. It is this thing here. Hopefully you can see it. Alright, let's check this out. We have a barge here that's being pulled by a rope here at some angle theta by a horse, and it's in the middle of a river here. And we're looking at a top-down view, and we are told a couple of different things. We're told the magnitude of this tension, we're told the magnitude of this angle, we're told the magnitude of the acceleration that's parallel to some x-axis, which I'm going to draw and have in the standard way here. We're going to have x and y. The acceleration then will go along this direction here. This will be just your acceleration A. Once we have this, we need to draw the free body diagram. So what we'll have is our barge here symbolized by this square. We have two forces acting on it. Remember, we're watching a top-down view, so we have two forces acting on it. One is the tension that goes this way, label it T. It's at some angle theta with respect to the horizontal. And the other force it will have is a drag force. It's the resistance from the water in this case. Because we're told that there's only an acceleration in the x-axis, and no acceleration in the y-axis, we can guess that the drag force will have some component of it pointing downwards, and we can guess that it goes somewhat this way here, somewhat down and to the left. And this will have some angle phi with respect to the horizontal. Notice that I have these two directions here. I'm going to only look at these two small triangles and consider the direction from within. We can split these two into their components. We're going to have here the force from the water vertically here and horizontally here. These aren't vectors, and we have that. Then we have the two components for the tension here and here, and then we need our x and y axis again using the regular ones. Once you've drawn the free body diagram here, we need to write down Newton's second law in x and in y. Starting in x, because we need to choose, we're going to have the following. So we have some of the forces in x is the mass times the acceleration in x here. We look at our diagram, we have only two forces, and those two give us an acceleration that we have in x. So we're going to have positive x-axis, tx, negative x-axis, Fwx, the force from the water in the x direction, and all of that will be equal to the mass times the acceleration in x. The acceleration is positive, positive sign here, negative component, positive component. Ultimately, we're looking for the magnitude of the drag force by the water, Fw. So to do that, I'm going to find the two components here constructed to be a right angle triangle, and then use Pythagoras to find that. So first, all that I need really is to find Fwx, and that will be it. Then I'll do the same for Fwy, and then use Pythagoras. That's the plan. So, going at it, we get Fwx is equal to which gives you, in the end, when you plug in your numbers, squared as your acceleration. So you'll have noticed that I haven't written down what I know and what I want here. Please do that. Once you calculate all of that, you get to 4 sig figs, 6,373 newtons. And that is your magnitude of your x components. And we resume with y. Okay. Sum of the forces in, not x, y is equal to the mass times the acceleration. In y, we have in green the tension. Tension in the y direction goes with the positive y axis. It's positive here, so we'll have Ty here. We have a component in the y direction for the drag force. It's going in the negative y direction, therefore negative Fwy. And we have here 0 acceleration in y. What we're told is that the acceleration is only going in the x-axis. The barge isn't crashing into either bank of the river, essentially. And simply write the next bit here. Again, plug in our numbers. Fix 2,441 Newton. We have our two x and y component for the drag force. All we need to do is use Pythagoras and the arctangent to find first the magnitude and then the angle of this drag force. Part A, we wanted to find what this magnitude of this drag force was. And when we plug in our numbers, we get 6,825 Newton rounded to 3 sig figs gives you 6,830, which means that I made a slight mistake in my earlier calculation when I typed in the answers. Don't worry about it. Next bit is part B. We want to find the angle with respect to the positive x-axis. So first we need to find the small angle phi. We're still working within that triangle that we constructed, and then we'll expand that adding 180 degrees. So to find this angle, we'll use the arctangent. All of this here, and once you calculate that, you get 20.9587 degrees. What we really want is this angle here. That is the angle that's interesting to us. So that angle is, I'll call it theta W, 201 degrees rounded to 3 sig figs. And there we go.